In this video, we're going to talk more about arc length of a circle, as well as talk about sectors of circle and how to find their areas. So in the earlier video, the idea was if you have a circle, radius r, and you travel around some distance, that distance there is called the arc length. We usually use the letter S for it. I don't know why arc length is S, but it is. And what we saw was that S is equal to R times theta, as long as theta is in radians. So you can just multiply the angle that you moved along times the radius, and that will tell you the distance that you moved along. Now, if I wanted to give a version that was true for degrees, the idea would be is you first start with theta in degrees, then you need to multiply it by pi over 180 to convert it into radians, and then you can use the formula S equals R times it. So this would be the more complicated version if you had an angle in degrees. It's generally not written out. We usually just use the simpler formula S equals R theta and then separately convert from degrees to radians if we need to. Now finally, that's the arc length. If we want to talk about sector of a circle, it's going to be the same picture here where we are traveling along the outside of a circle, but this time the sector is all the area inside rather than the distance along the outside. So it's this area part here rather than a length. And once again, we have a nice formula for it in terms of radians. It's going to be 1/2 r squared theta if theta is in radians. 1/2 r squared times theta. You can just check to make sure that this does seem to work. If you have a whole circle, that's when theta is 2 pi, and you'd have 1/2 r squared times the angle 2 pi, which simplifies to the normal formula for the area of a whole circle, pi r squared. So it's at least reasonable here. If you wanted the version for in degrees, we could also do that. Again, it's rarely ever written down because it's not really that helpful. But you have to just add on a times pi over 180 degrees there. Theta in degrees. So we have arc length problems, we have area of a sector problems, and then we're going to have applied problems based on these. And one example of that is a Ferris wheel problem. So let me try to draw a Ferris wheel on here. It's not going to be a great picture, but we'll do what we can. And I'm going to go ahead and give you some numbers here. So the radius of this Ferris wheel, let's say it's, I don't know, 100 feet here. Let's say the distance from the center of the Ferris wheel is to the ground down here is 120 feet. Let's say that, go ahead and draw a little compartment for someone to sit in on the Ferris wheel here. And so the idea is you get in the Ferris wheel, it turns on, you start traveling around the edge here, and we're going to say you get to a new point, and I will tell you that the angle, a different color here, so the angle between where you started at and where your thing stopped at for them to get the next person on is 30 degrees. And then we're going to say, how far did you travel while in the compartment as it traveled 30 degrees around its full rotation? So how far did you travel while riding inside, as we've gone 30 degrees? So the first thing I'm going to do is I'm going to convert that to radians because I like using the easier formulas here. So theta is 30 degrees, which if I want to convert that to radians means by pi over 180. And I get pi over 6 there. Once I have that, then I can see what am I trying to do. Am I going to use the area of a sector formula, or am I going to use arc length? Well, the question's asking us how far I traveled as I'm moving along the edge here. So I use the arc length formula. I'm not going to use the area of a sector for this problem. If they had asked how much area was in that shape, then sure, but I can't think of a Ferris wheel version that would care about that area. So we go ahead and use S equals R times theta. Even though I told you the 120 feet, we don't need it right now because all we need is the radius of the circle, which is 100 feet, multiplied by the pi over 1/6. You can reduce, divide by 2, and that means we would have 50 pi over 3 feet. That is the distance we traveled. If we'd like to get an approximate value as a decimal, let's say round to 1 decimal place, this means you traveled about 52.4 feet in the air. Okay, so this is the first of the Ferris wheel problems we've seen. We are going to see more as we, for example, look at how high off the ground we might be. That would be a separate question. We could ask, what is the angle when you reach a certain height? There's lots of different variations on Ferris wheel problems. This one specifically deals with arc length. That's why it's in this video. But we'll see more in the future.